Alright, here we are at the final video in the precision game. All of the graphics are now done. Of course, these are new graphics, so they are going to look slightly different. But as we said right before we brought Zach in to work on these graphics, we were going to have him do everything at 64 by 64. Now, 64 by 64 is going to cause a little bit of trouble with our game, but we didn't want him to have to worry about all of these different resolutions. As a matter of fact, you're going to see that even we are not worried about all of these different resolutions. But what we need to do is to fix his graphics now so they work properly in precision. And you may be wondering, why do you need to fix them? So Logan, I think the first thing we should do is just demonstrate to them what would happen if we used Zach's graphics straight out for precision.
Well, what we could do is go to the source folder. I've moved the graphics out to this the source folder directory.
And not only that, we've also changed the names of the graphics as well because, you know, Zach had things like probe. It was actually player. We didn't give him any specifications for what to call all the graphics. So once he had everything named and we knew what each graphic was, we simply changed the names so that they matched all of our names accordingly.
Right, that would have been changing antibody to enemy, probe to player.
Exactly.
And getting the time power up, getting all those set up.
Exactly. So now that we've got all of those in place, these are his graphics. We have not done anything with them. We can simply grab these and copy them over the graphics that are over inside our game right now.
So if we go to our game's textures folder, here we have the project for precision, and then the textures folder contained within. We could simply paste these over the existing graphics, then go back to Visual Studio and rebuild to get those graphics accounted for.
Okay, and now if we launch, things are going to look a bit different.
So already we can see the cell and the enemy are a little bit different as we play the game. The colors of things are different. But check this out. If we advance to the next level and then look at the collision with the player and the side of the walls, the player can't actually reach the edges of the screen anymore. This is because the player's graphic is set to 64 by 64 when the physical colored pixels are less than that. That means we have a clear border around the edges of that graphic.
Right.
And since we're using the entire original texture size to account for collision, that means we're going to collide before we visually collide, even with enemies.
Yeah, all collisions are now
messed up. If I move over to the
up.
enemy, I collide before we get any type of visual indication.
Exactly. So what we're going to need to do is chop these graphics down now so that we only account for the colorized pixels, not all of that extra transparent space that is around them. Now, also, let me point this out. You'll notice that the background's real bright. The cells are a little darker in color. This just comes down to previously when Zach created all the original graphics. As we put them in, we then turned around and asked him, hey, could you darken this up? Could you brighten this a little? Could you tweak the contrast with this? We just did a little bit of back and forth, utilizing techniques he's already demonstrated inside of Photoshop to you. Basically, use these techniques to adjust the graphics until we got the look that we were wanting. So right now, what you guys are looking at are kind of graphics in a raw state where he's just handed them. It's the first pass, and we would look at them in this case, and like with the background, we'd start out by saying, all right, could you take the background, make it a little darker? And he would do just that and hand it back to us. Of course, we're not going to record that because all that would do is basically result in the graphics looking exactly like the original game, but everyone's already seen how they can go about adjusting brightness, colors, etc. So I just wanted to throw that out there real quick. So let's go ahead and close out of Precision and jump over into Photoshop real quick. Now let's open up that CS folder and let's drag everything but the background over into Photoshop, and now we can make some adjustments.
All right, the adjustments I want to make is I want to take these graphics and convert them so that I make new graphics that have the border cut out.
Okay.
So that way the physical colored pixels go right up to the edge of the actual graphic. And I know, and you may have a different technique that you like using for doing that. What I found is that the way Photoshop works with copying and creating a new document is the new document will have only the size accounting for the colored pixels, not the clear space. Which means I could take this time power up, hit Control A, copy everything, hit Control N for a new document, and then...
Don't hit new yet. I want to point out one thing. The background contents. Make sure, because when you guys were watching Zach work, he likes to work with a white background, and then at the very end, remove that out. Well, make sure that you set your background contents here to transparent, okay?
Right, because we still need a transparent background
That's right.
in the end, so we need to make sure we do retain transparency. The key here, though, is if I paste this in, as a matter of fact, if you were watching the size of this document, it probably had some slightly off size. So if I paste this in, check it out, all of the borders are gone. Now we're not going to worry about the exact image size here because XNA seems to do a great job of whatever needs to take place in the conversion process when it builds the XMB files. It actually handles these just fine. Now, in a more intense game where you're looking at efficiency down to the pixel level, you might want to come up with some way or some design spec to make sure that the graphics are physically hitting a specific pixel size. But here in Precision, we've noted no problems from doing this. So with this new graphic now, let me do Save As on the graphic, and I'm going to jump inside the Output folder. You saw inside the CS there was an Output folder. That's where I'm under now, so I'll save these out, again, as PNG files. And this was the time power up. So we'll save that. Then we can close the document out, and then we're done with the time power up. Now we can address the player. Select everything, copy into a new document, which is now 28 by 28 instead of the original 64 by 64. Paste this in, save as, player.
Yep, PNG.
And we need the type to always be PNG. Save, yes, and we're done with the player, the original player graphic. Now the enemy. Select everything, new document, and
we got to copy it.
Copy it. Then I noted the file size. I was like, okay, that can't be right. Then save as enemy PNG. And we're done with that. We're done with the enemy graphic. And finally, the cell. Copy everything to a new document, paste it in, save as cell.png. And that's everything.
Outstanding.
Now we can bring the games directory back up, and we can bring these files up. Now I can go to the output folder, copy all of these, paste them into the games textures folder once again, go back to Visual Studio, rebuild, and now we can test the collision on the new graphics. So first, the player hitting the edge of the screen. Yes, the player can indeed hit the edges of the screen.
Very nice.
Then enemy collision happens visually. So we actually have to physically touch the enemy graphic for a collision to take place.
Excellent. And that's it. It's that simple, guys. Of course, at this point, you might want to make some adjustments to your graphics just so that the colors look good. But Precision is now finished. Congratulations. You have completed your very first complete XNA game in the XNA Xtreme 101 class. And with that, that is going to wrap everything up. Wraps up Precision. Thanks a lot, guys.